So WISE, with intelligence, see everything. So what is it? It allows you to enhance the SPI data for a session. So basically, for every session that goes by, it can be sent off to WISE. WISE is aggregating multiple intelligence feeds, either commercial, free, or just ones that you create with files, and adding fields to your session. Now, you'll see examples in a second. But the data sources can be anything. They can be files, they can be URLs, they can be commercial services. You can query Splunk, Elasticsearch, Redis. We've added a bunch of different data sources. And there's multiple layers of caching so that you're not hammering these commercial services, you're not hammering the WISE system. Just a really quick example before we go into more detail. This is what it would look like with Threatstream. So let's say I had a session that I opened up and I saw this. This means that there would be a section, and these are the Threatstream results for that particular session. So this session was very high severity, and it gives you the malware type. You can actually click on the Threatstream ID and go right into anomaly, whatever they call their interface, detect or something. And you could see even more information. But this is what comes from their database, the Threatstream database. And so this is what you would see in the session view. And then even more powerful is this is what you see in the SPI view, where you can look at all the different fields, and you can, for whatever expression I had used, here's all the different values for just Threatstream. And then you would have a different section for each of the things that are coming for WISE. So Threatstream is one example, and then we'll go into some other examples that you can add yourself. So what's the architecture? All of the capture systems are going to be talking to WISE. There's a cache on each of the capture systems. It's really small. It's built into the capture process. So it's going to itself try not to go to WISE for every single query if something is popular or recently happened. Then it goes into the WISE. The query then goes to the WISE system. The WISE system itself has a cache, and you can use a Redis cache if you want, so that if you have multiple WISE servers, they can share their commercial results in the Redis cache, or you don't have to do that. That's an optional feature. And then if it doesn't have that in any of those caches, it's going to go off to the service, or the data source is what it's called in WISE, to get the result. Make sense so far? So I'm going to go through some basic configuration, because this is a common question that keeps coming up on the Slack channels. I realize that the WISE documentation really needs to be updated, and that's one of our goals for this year, is to get some better documentation. I'm always asking for help from the community, because things are obvious to me, right? I wrote it, I know how it works, and things that are not obvious are coming from you. And so when I get a question, I try and update the documentation, but definitely could use help from folks. Documentation is on the wiki. The wiki is available for anybody to edit. That means you. So you have to do two different configurations. You have to do the configuration for your capture and viewers, and then you have to do the WISE configuration. The capture and viewer configuration is just pretty easy. You're just going to tell you're just going to tell the capture and viewer processes where the WISE server is. And so you're just going to set ports, hosts, and then you actually have to tell it to load that plugin. WISE is implemented as a plugin. I'm a big believer of using the plugin systems that a software package implements, even for features that are included, just so that we know the plugin system actually supports things. So WISE is written as a plugin, even though we deliver it with Moloch. And then for every data source that you're going to have, there's going to be a configuration also, and it lives in WISE. So WISE has its own configuration file also, and basically it's done per data source. In some data sources, there's only going to be one of them. For example, Threatstream or OpenDNS. You're just going to have one section because there's only one Threatstream that you're configuring for all of it. Other data sources can have multiple, and those have prefixes, like your Splunk queries, your file queries, URLs. You're going to have multiple sections in your configuration file. And then we offer a bunch of different common options so that you don't query everything for certain URLs or IPs or domains. So if you know you want to exclude things like spam hosts or whatever from going to OpenDNS or your your blacklists. If you don't want to query OpenDNS for those, you can put those in exclude lists, and every data source inherits that functionality. And so per data source, you can say, don't ask this data source for these IPs or whatever. There's lots of configuration options. They're all in the WISE wiki. So here's a very simple sample configuration. The first section is global here, this WISE service one. And we're basically saying we don't want to ever look up these things. These things, if they somehow end up at WISE, just don't look them up, just drop them. And then we add two more services or data sources here. We add this very simple reverse DNS one, where if the IP is in the 10x range, we're going to look it up, and then we're going to set this asset field. So what happens is every single IP address is going to come over to WISE from the capture system. The capture system is going to check all its caches, and if it's in this 10x address, it's going to look it up and then set the field. It's going to go back and tell the capture process, for this session, set the asset field to whatever it reverse DNS looked up. And the second example here is you could have a file called bad IP. And in there, you can have all your really bad IPs, the super bad ones. And if that super bad, and if that ever happens, if those ever get hit, it's going to set a tag called bad. Next, I'm going to go over an IPAM example. So we have several different methods for getting our IP address space into WISE. And this one is one we created just from a JSON query. And this is what our end UI looks like. We just have two different sections that are created. This top one here is what you're going to see in your sessions. And this is an example of SPI View on the bottom here. And so I'm going to show how we implemented this. It's all through configuration. So we create a new configuration for the IPAM where we're saying it's going to be a data source of URL. That means you have to go to a URL to get it. And we give it a name, IPAM. What we're searching for is IP addresses. The format of the data that comes back is JSON. The URL to go get the whole JSON file of all of your IP address ranges is this sample URL. We're going to reload it every 60 minutes. And so what this is doing at a high level, and I think I have a next, it's going out to this URL every 60 minutes and downloading a file that looks like this, where this is just the file that we happen to have here, or we used to have here at AOL. It's just 3 fields. It has what the data center's name is, what the security zone name is, and the CIDR. And it just has that for all the IP addresses that we know about. So what this is doing is every 60 minutes, it's going to go get that file. The field that we look up on is this CIDR field, and we automatically know how to process CIDRs. We didn't have to do anything special. It's not even name-based. If it sees what looks like a CIDR, it will look it up. And then these are all the fields that we can set. And so you have to configure what fields you set, and it's kind of a complicated language, but there's examples on the wiki, but this is creating 3 different fields, the same fields that we saw right here. I'm sorry, 4 fields. It's creating these 4 fields. So that's how the fields are defined, because Moloch needs to know the type of each field. It needs to know if it's an integer or a string, basically. And that's all you have to do. So you just create this, it goes out to that data source, gets the data, and then every IP address that comes in, it's going to look it up. I feel like I went fast, but does that make sense? Okay. Lunch is here, so I'm going to go faster. Elasticsearch. So here's an example of how to go to Elasticsearch to get data. In this case, we're going to get the username from a panos logs. So for this, we have the IP address of the traffic that's going by, and we want to get what user that is based on our panos logs. And we threw our panos logs into Elasticsearch using Logstash. This is very similar to what we just talked about. We configure our Elasticsearch URL, what Elasticsearch index to search on. We have to tell it what timestamp to use because we want to make sure to get the latest log, since the IP could be handed out by the VPN server concentrator at any time. What field to do the query on, where the username is going to come from. And this is what a record looks like right here in Elasticsearch. It's going to have a source IP field, source username field, and the timestamp field. And so we know to go in there every time we see a new IP address that's in this range, because this 1010 is the IP addresses that we use on our VPN concentrators. That's what we hand out in this example. And so we know to go look those up in Elasticsearch. Boom, we can map 10.10.10 to Andy Wick in all the traffic. So now if we opened up any traffic that's 10.10.10.10, you will see Andy Wick. So recently we've switched to Splunk for some of our, or I guess all of our data. Josh loves Splunk, make sure you talk to him. It's the exact same idea. Here's an example. This one is actually a Ansible playbook or template. We're filling in our username and password from Ansible as the file is deployed, but it's the same idea. Where's our Splunk endpoint and port? The format's going to be JSON, and here's the query that we send to Splunk. I don't know, it looks Greek to me, but it's a bunch of things with pipes in between it, and it somehow gets the thing out. Here's the VPN log. I guess that's the same as the index. I mean, the one thing that's nice about Splunk compared to Elasticsearch is everything is in that blob instead of having to be configured everywhere. You just paste in one thing. But at the end result is this is going to get a table of all users. So one of the differences between the Splunk implementation and the Elasticsearch implementation is for Elasticsearch, we only support a query per thing. So you look up an IP, it goes to Elasticsearch, it looks up by that one IP and gets a result back and does that. Our Splunk implementation supports that, but it also supports a table version, which I'm told is better for Splunk, where Splunk, you just say, give me it all. Like, give me all of the users that are on the VPN, and I will cache that for a certain amount of time. In this case, it's 60 seconds. So for 60 seconds, every 60 seconds, I go to Splunk and I say, give me all the VPN users. Instead of going to Splunk for every single IP one at a time. We could implement that for our Elasticsearch one, but currently we don't. But Splunk supports both of them. So this is the table one. So what this is doing is it's getting back a table of just two fields, the user and the VPN IP. And just like the Elasticsearch version, it's going to set the user field for every IP that matches. Right clicks, Elasticsearch supports, sorry, Wise supports Wise supports Elasticsearch. Wise supports right clicks. There we go. So it can send the right clicks to the viewer. So one of the things that some folks do is they like to add right clicks to all of their viewers, and they have multiple viewers, and instead of having to do that configuration all over the place, you can just do it in one place, and that's in Wise. And our right click format it's kind of ugly, but it's nice and convenient, where it basically can fill in parts of the URL with results with the fields that you're right clicking on. So you can make it so you can click on any field in the viewer and it will have new right clicks show up. And they're actually not right clicks anymore, they're now left clicks, but they're still called right clicks. One of the big changes we did with the latest version is instead of having to write all of this to create a new view, you can now just write a view for one in one line, which is basically just a comma separated list of all the fields you want to show. So if you're creating a new data source, or if you're using the tagger file format, you can now just do this one line format for what the view will look like, so what the fields will display as, instead of having to write this really long format of, I guess it's a pug format file. I mentioned this earlier, but Wise now supports the ability to search almost any field type. And there's two things that you can do with this. You can also add fields to established Wise types. So in your configuration file for capture, here we have two examples. One where we create a new one, which is this MAC type. We're just going to call it MAC. It's for MAC addresses. And we're saying that the MAC address type is made up of the source MAC and the destination MAC. And the example here is trying to show that you can either do it with the DB field name, in which case you do DB colon, or you could do it with the expression name. And that's what you would type into the search bar. In either case, when a session is indexed by capture, if it has a source MAC address, a destination MAC address, or both, it's going to send it over to Wise as this MAC type. and then any file that you have there as a MAC type will automatically look it up and send the fields back. And the same here for MD5. MD5 is already a type that exists, but we wanted to add blah blah.md5 as another thing to look up. So already we look up HTTP MD5 and email MD5, and we're adding a third thing, which is blah blah MD5. Cool. So some of the things we want to do this year to WISE to make it better is we want to make it even easier to add new sources, especially one that require code. Right now it's kind of complicated and not documented very well. So that's a big thing that we're doing. We're going to also add some UI to WISE so that you can actually go to a UI and do things with WISE. Right now you can have an API, but it's kind of hidden. So we want to make it easier to use. We want to support multiple WISE servers on one machine better. Right now, if you run multiple WISE servers on one machine and you're using a commercial web service, each of those WISE instances will go off and query that commercial service, where since they're on the same machine, they could share the data. We're going to move it. It probably doesn't matter to most of you, but right now the WISE source code is kind of buried deep inside of the tree, and we're going to move it to the top level and make it so that it's clear that WISE is kind of a top level thing. And we had this for a while, but we want to add back bro support. So we wrote a bro script that would query WISE and tag data in bro with whatever WISE knew, so that you didn't have to create all your files in the bro intelligence format. So we want to do that. And then we also want to do the opposite, where we support the bro intelligence format files with WISE. So it's a two-way sharing of data. It'll be easy to make it so WISE supports bro. Or Zeek, sorry, Zeek. I do use that in a different presentation. I do remember, but not this one. Nope.
Where does the processing happen with WISE? So you're fetching info from different sources. Where is it actually enriching and tagging and all that? Up there.
So the enriching is done in the capture process. So the actual capture process, the session is completed. It's about to write it to Elasticsearch, and it sees that WISE is installed. It will go to WISE and say, do you want to enrich this session in any way? And then it waits for WISE to respond, and then when WISE responds, yes, no, or here's how I want to do it, it then is when it sends it off to Elasticsearch.
And you were mentioning a bro plugin, potentially the same thing in bro, right? To have it tag it for you.
Yep.
What is your opinion on, how do you see a big picture workflow, right? So bro could tag it, WISE can tag it. Like, what do you think makes more sense? Would someone use a platform like this?
So it all depends what you're trying to do. A lot of people love bro for doing everything and don't even really want to use Moloch for this type of thing. They would rather have it all in bro. And so our thought is, right now, at last time I looked, bro doesn't have something like this. They're more of the, you can correct me, but they're more of get all the intelligence, create all these special files, send all the files to all of the sensors. They're all local to the sensors. Reload bro, or tell it to load the new files, and it's all there. As opposed to WISE, which is cache it at the sensors, so you don't have to go to WISE for everything. But no, instead have central locations that actually have all the intelligence loaded, and so the bro servers just occasionally go off and get it. And is that still correct?
So the intelligence framework will let you send files to the box, and then it'll automatically load them up when new things are.
Right, but all the files, like, you have to have the data replicated everywhere on all the sensors. Yeah.
Exactly.
Do a lot of people ask about reprocessing and that kind of thing, right? Because these feeds change, and maybe an IP is bad tomorrow, good today, etc. Do people ask, like, well, how do I go back and retroactively retag, or is that not a thing? Like, that was a point of time. Do you kind of see it as a point of time snapshot? What's your opinion on that?
My opinion is that it's a point in time snapshot, and which is why the fields are added right as it's added to Elasticsearch, because of that exact reason. The IP was bad then and good now. You don't want to look up the IP now when the analyst opens the session, because it's could be wrong. You want to look it up. You want to know what it was back then. But yeah, I mean, for people who load PCAPs, they're kind of stuck. WISE is not as useful.
Hi. So heard you say that Moloch capture is going to send the session to Wise
Mhm.
before it gets indexed. Yeah, back on the architecture page. So how will Moloch capture behave if, say, the upstream source is non-responsive, or so say my Splunk server's down, my Elasticsearch server is slow to respond to some enrichment request. Are there any, what are the, how long is it going to wait for that enrichment?
There's configured timeouts. I don't remember off the top of my head. Let's pretend it's a minute.
Mhm.
And then eventually it will give up on Wise.
And then it will get indexed into Elasticsearch. So the
Yes.
session won't get lost, but it won't get enriched.
Correct. Though, okay, there's two exceptions. Okay, so first of all, if Wise has timeouts between its data sources, it will send back what it already knows. But if Wise is down, then Capture will send to Elasticsearch what it already knows. The one exception, and so we keep flipping flop on this, but I think if you start up Capture and Wise is down at startup, it will say, I can't start. But I think if Wise goes down while Capture is running, then everything is okay. I don't know. Is that wrong? I don't know.
So somewhat on that, expanding it, can you have a hierarchical set of Wise servers?
It's actually there. You can make it so that you may have one Wise server that does all your OpenDNS queries, just so that it's all cached there. And if they, or you're going to a service that rate limits you, and so everything that goes to the first Wise server, that Wise server knows to go to another Wise server for some other commercial source, so it's all funneled. You can do that.
Well, I'm thinking more of like if you're rolling out to, say, customer environment where I don't have the ability to reach and touch the Wise server in their environment, it needs to pull information from another server that I would own, and then I would update that server, and all their Wise servers would query mine for today's information or the
Yes.
second's information.
So that's just like this, the IPAM example here, where it's going to go off and get a URL that has all the data periodically. In this case, it was, I think, once every 60 minutes.
Okay.
I think that's what you were asking.
Yeah,
It's
yeah,
just a flat file on there. You could do it with Wise. You could do it both ways. You could do Wise to Wise, or you could do Wise to an URL to get the file.
Well, I'll probably end up having in my customer environment, the probe and the viewer would be on one box that
Right.
live in their environment, but probably not another Wise server in their environment. So I would have a Wise server that would be over the internet as opposed to locally. And I'm worried that if it's not able to query in time or get information back in time, then it will start to hit the ability for it to post stuff into Elasticsearch properly quickly.
So it's going to start. I mean, you would want to fool with the knobs there to lower the timeout probably. I think I've answered your question.
Yeah. My question is that like for Suricata, like if.json, those files, you can hook up with the Wise as well, right? Like alert.json in Suricata.
So
we can use those files to consume data using the Wise or no?
you could, yeah, you definitely could. But the Suricata plugin is a plugin into Capture. It's not a plugin to Wise. Just to be clear. But you could have Wise load the Suricata data.
Okay, thanks.
It can load anything that's JSON. We have 4 different formats. I think we have JSON, CSV, what we call tagger format, which is our own. I'm missing one. As long as it's those, you're good.